Hey, how's it going? Welcome to another episode of AngularAir. I am your host, Justin, and today we are going to be talking about extending Angular for the reactive web, some reactive programming stuff, probably some performance stuff, some exciting stuff around that. So looking forward to it. Let's say hi to our panelists, and then we'll meet our guest, and we'll get right into the content. Joining us today, we have Alyssa. Alyssa, how's it going?
Hey, so glad to be here.
So glad to have you. Mike is with us. Mike, how's it going?
Not too bad. Happy to be back talking tech and hanging out with a few good friends.
All the group. Bonnie's with us. Bonnie, how's it going?
It's going good. I'm over here in Europe. I want to throw something in before we start the show, if that's okay, because
Absolutely.
I'm watching the news over in America. There's scary stuff going on over there, so I just want to give a quick shout out to Black Lives Matter. There's some people fighting for justice, and I support them. And if I can start out with a pick real fast, Equal Justice Initiative out of Atlanta. There's a guy named Brian Stevenson out there who's been doing really good work. And also, as far as nonprofits go, they're really good accountability, really good transparency, and they're fighting for equality in the justice system. So, yeah, I just wanted to get that out there before we jump in.
Thank you, Bonnie. Thank you. We'll be sharing that link that we can put up. We'll put it up on the description of the video and share that out.
I'll send it to you.
Awesome.
And who do we have tonight?
Who do we have? Michael's joining us. Michael, how's it going?
It's amazing over here in Europe. It is the end of the day, I would say. So the last bit of my energy is for you.
Awesome. We appreciate that.
You see?
Yeah. I really like is that a just full-blown bookshelf that you got behind you? Or is it multiple things?
Yeah, this is a bookshelf. I moved it there because it looks good on the camera.
Have you read all those books, Mike?
It's my office, and those books are not my books. These are the books of my wife. And only a very small portion, like here, this one, are my books.
Ah!
The red is Joanna's books.
Oh my goodness.
Yes.
So, Mike, you have a very smart wife.
That's true. But I'm not really smart, so it's also easy to be smarter than me.
Awesome. Why don't you want to tell our viewers a bit about yourself?
Yeah, my name is Michael Hladky. I always say Michael, but in fact it is Michael, German, but yeah, English, German, however. Maybe let me say hi to Mike. Hi, Mike.
Hi, Mike.
It was a running gag at Entwicklung. I'm sorry. And I'm a trainer and software consultant with a focus on Angular, Ionic, TypeScript, everything in this ecosystem. And my hobby is reactive programming. And this is, I guess, also a big part of today's discussion. And whenever I talk about it, I'm very happy. A little bit more happy than normally.
How do you get reactive programming to be a hobby is my question.
Well, it's kind of a while ago since I tried it the first time. I was just starting with this web technology stuff, and AngularJS was the new kid on the block. And then I went on a meetup, and they said I said, what is the newest shit that I want to try? And one said, AngularJS, and it's so cool. And I'm like, oh, I will try it. And then another guy interrupted me and said, no, rxjs is the new shit, and you should try this. And it took me a time to learn this Angular stuff. And then the first experiment with rxjs was getting a button click stream, the one-liner from event. It took me 3 days to figure out what should I do here. Yeah. And I managed it somehow to do a very basic demo and gave a presentation back then. Lost a little bit of focus and came back half a year later to the same topic. And since then, I was so fascinated about this, and it was also so hard for me to learn it that somehow I couldn't get rid of it. And if you put a lot of effort in something, like trying to understand this whatever library, it gets a lot of value for you from a psychological perspective. So I cannot get rid of it because I put it so much effort to learn it that it sticks with me now.
I was stuck about 6 months on trying to figure out the difference between RxJS and NGRX because the letters confused me a lot, and I just was like, I don't know, like, do they go together? Or are they like competing? Or I couldn't. So all the letters was crazy for me. And then what it actually does, it was a while for me to figure that out. But once you master React, especially because even since then, where it's grown, that it's become such a part of, I mean, rxjs is like, if you master reactive programming, then it's such an essential part of Angular, because it shows up in everything. So it's kind of good that you became such an expert on that.
That's true. I mean, Angular is for sure not implementing more reactive features. I would say they try to limit it where they can, which is valid, of course, but this is not a problem, because you can do anyway always everything on your own, and it's not hard to set up a behavior subject. So I guess the value is not for me only in the Angular ecosystem, but you can use it also in all the other frameworks, right? You can use it in
absolutely.
Any framework you want, or vanilla. And the coolest part is it is the principle. It's push-based processing instead of batch-based processing. And this is something that, for example, Alibaba, they turned their whole infrastructure from batch processing to push-based processing in the backend too, because otherwise they could not survive anymore. It took too long to get the number, how much money they have today. It took too long to get a number of something. And they really switched their whole ecosystem to stream-based programming, and in the backend, in the front end, and this is the way they survived. So you can use it on the full stack.
This reminds me of Thomas Burleson was on our show last year with the push-based architecture, and it was such a good show, and it was very good. Yeah, and so are you. So, and you have slides for us and everything. You're going to show us. You're going to talk more about this.
I want to add one thing real quick. You talk about also using rxjs on the background or in the back end as well, not just in the front end. I just wanted to explain for those who may not know is that rxjs is part of a larger ecosystem called Reactive Extensions, and it's available for a lot more languages than just JavaScript/TypeScript. So whether or not you're doing .NET, Go, Ruby, Swift, Java, there's a whole bunch of different Reactive Extensions. So if you're using a different programming language other than JavaScript/TypeScript, take a look. You may be able to find Reactive Extensions for your development environment as well.
I was under the understanding that it was new only to JavaScript, but that reactive programming wasn't new to a lot of backend languages. Is that not true?
That's true.
rxjs has been around for quite a while. Obviously, popularity has grown quite a bit, partially thanks to Angular, but it's been available for multiple languages for quite a while. So you can use the same paradigms and the same concepts across different programming languages.
There is even, it's called Apache Flink, I guess. It's for the backend. It's also reactive programming, but this is a completely different, let's say, library. And if you look at it at the code and you see like, it's rxjs, or Rx in general, but it's just like bringing the concepts, and also they have the names like switch map or whatever. So it's like a language, right? a meta language in programming languages.
I always find it interesting that it's like the concept is complex, right? There's a lot going on. The code is pretty straightforward and feels pretty clean and light. So it's like something that's light and small, yet is so shiny and exciting. And I think maybe it's because I think about it in terms of it's different from a lot of the stuff that you do in terms of how you approach programming in certain ways, right? And so it's this new, different. Well, it's not really new, but it's just different, right? And maybe that's part of why it makes it so exciting. Because you talked about like, oh, it was so excited about getting into it and stuff like that. Like, what is it that makes it so exciting, right?
Yeah. So, should I open some slides and we see what we want to talk about?
You should. Yeah, we have a double header tonight, so we have to jump right in there.
Yeah,
teach us something, Mike.
We will have a cool conversation, and maybe we'll have fun, and maybe we'll learn something.
I always like to crash Mike's workshops at conferences and give him a hard time and give his students a hard time. And I always try to dig up dirt on him, like, hey, is he mistreating you? How are you guys doing? And he's mistreating the students, but they love him. And they're always so happy with him. And they're like hugging him at the end of the class, but he's picking on them a lot. He's a lot of fun. He's a goofball, but he is a really good teacher.
Okay. I jumped real quickly over some slides, and maybe we can also talk a little bit while the code is open. In general, I want to talk about the current state of Angular, what tools I'm working on, some demos, and the roadmap. And let me start with the current state of Angular. Angular is, if you work in bigger application or in very interactive applications, you have a lot of stuff that is going on, a lot of behavior, a lot of state that you need to manage, and a lot of interaction from different other modules, the user or the backend. And this is a mess. If you look at this picture, this is what my code normally looks like when when I start into a new project and just do something and don't focus on certain principles. And this leads to a lot of potential bugs. And what I did over the time is I nearly in general write fully reactive applications because it's way easier and it is way more robust. The code is slim, and you have way less side effects. So I used rxjs to do this in Angular. There are different reactive programming libraries in JavaScript. There is also Bacon.js in this stuff, but they have some different concepts that it is not so easy for me. I would say it's not so easy to have an observable that is always hot. This is, for example, the difference to Bacon, and it feels harder to reason about the code. So I really appreciate that rxjs is what it is today. And what I will use it for is to introduce some organization of processes in events, and I will also introduce a good separation of responsibilities, a separation of concerns. Where do I get my state from? How do I change the state? And this is basically the whole goal of this conversation here, to get a good understanding what's the problem today and where we should go. So Angular is, as we know, pretty reactive from out of the box. But if you want to write fully reactive applications, it's half reactive, right? On the service level, we have really cool things like the router, HTTP service, and other stuff that brings us reactivity. On the component level, we are a little bit less well equipped. We have the reactive forms and maybe some push pipe and this stuff. No, push pipe is in a template layer, yeah? And then the template layer where we have only the async pipe, not only the async pipe. And if you ask me, the async pipe is pretty boring to use. We could do way more with this little thing than we think. And what you end up normally is...
The async pipe is fascinating, Mike. Take it back.
The async pipe is boring. It's official. I said it. After the talk, you are convinced. Believe me. So you end up with this custom glue. The Black Sea is a custom glue, and then you have the router and this stuff. And there are some parts missing. Let's say the reactive glue in Angular is missing on the component and template level. And as this would mean for Angular to write a second framework that is reactive, I understand that we cannot have a fully featured thing. So I started to write my own set of tools to tackle this. And I tried to bring applications that have a confused data and state flow into applications that are well more organized. And I do this with my set of tools, or the set of tools that we as a community, it's an open source repository and other people also work on it, build. And I am already introduced, let's save the time. I want to wait from a confused state to a state where we have a well-structured data flow. And then I will go one step further. We'll take this well-structured data flow and implement some stuff that will bring a lot of performance. In the end, we will have zone less performance in zone full applications. And this is, I guess, pretty amazing. So libraries are Rx Angular and Rx Angular template, Rx Angular state.
Oh, there you go. I don't know if our connection's kind of fading out.
I know. I was like, is it me? Is it him?
Mike, you might want to turn your camera off because we can still see your. Maybe we can hear your audio better if your camera's off because I think your internet might be cutting out a little bit.
I just want to say it can be confusing to have the same name as the guest.
We'll just call you Broccoli, and he gets to be Mike. So
we should call our guest Hladky.
Call me Hladky, whatever.
All right, sounds like you're back.
What?
So we can hear you good now. You cut out there for a minute, but
I was
just back up a slide and start again, Mike. You'll be fine.
Okay, I'm always fine. I hope so, at least. I pretend
you're doing
I'm
great.
Fine. So the overview of this state library is an API that is really, really slim and mirrored. You have two layers. You have the top layer, which is the reactive layer, and you can connect observables to this state, and you can select a stream of values from this state. And then you also have the imperative layer combined. You have set and get, which you can use imperatively. On the top, you have the $sign, and this is the observable as it is, the full state, so no selected slice, just as it is. And at the bottom, you have this hold method, and the hold method is here to hold some side effects that are not changing any state. And the same as the API, also the typing is really, really symmetric and easy. You can merge in partial of t, which is the state. You can get the state at the top, and you can get out partials of this state t. And this is basically the full API that you can use. And now I could switch over to some code, and I could start to ask some questions, and maybe we can have a discussion. So let me first open an example. I hope that the code is well visible. And you can see some lines of code now. Is it true?
yeah, I can see it.
Perfect. So when we start to use, for example, NGRX, which is a really, really great state management library, we have often a problem that we have to somehow connect it. So let's assume, where is my constructor? I have a service, and this service is my state, my global state, which is push-based. And I somehow need to use this together with some other parts of my application. Or another good example where this is an example where we always have to call subscribe, right? Because we have the chance to move it in the template. But if we cannot directly use the async pipe in the template, we have to somehow do some subscription handling with this stuff. And the other part where we miss some glue is the input binding. And this is basically a method that is not composable. I cannot get something reactive out of it. And this is the layer where I say, okay, this new library deserves to be the glue in a class. And what I want to do now is to show you how to connect uncomposable methods like this input binding or streams of values to the component state by using this library. So whenever I code a component, I start with the mental model that I try to write down what my component state is in an interface, that I can really know what state, what data do I manage. And let me bring in a little bit of database know-how. Maybe you know the term normalized data structure and denormalized data structure. An easy explanation for a denormalized data structure is a data structure that contains redundant information. If you have a list of my comments, and in every comment you write also my name, this is redundant. Maybe you should give just a foreign key to my profile and get the name from there. So denormalized means redundant information, normalized means non-redundant information. And my component state, my component model is normalized data structure, and my component ViewModel is stuff that I show. A good example on a ViewModel is I have the list here, and maybe I have the number of list items, items number here, and this is for sure related to the list here. So my number of items is derived from the array. And I can say array.length, and then I get the number of items. So I don't need to store this value here, and this is my normalized data structure, and this would be my denormalized data structure that I want to display in the view. And this is, I guess, a very good concept when you start with a component, that you think in these two levels, model, view model, and then you can have a clear understanding what to manage and what to derive. Just as a small intro. Of course, I have an initial state, and now I want to show you how to glue those uncomposable, unreactive things together. I will use my library. It's called rxAngular/state, and this has a state class, and here I can move in my component state itself. I hope that some of you are now screaming, why are you extending the class? Are you weird? No worries. You can also move this into the component constructor and inject it here. You can also put it here and could say, I want to inject my Rx state. The only thing that what you would need to do is you would need to provide your state here under local providers. This is the reason, because my Rx state is not a singleton. If you think about component state can never be a singleton, right? You have state in every component different. So what I do is, with this state, if I register it here, or if I extend the class, the component will, whatever you give him, the state will, whatever you give him, will automatically subscribe to it, and when the components get destroyed, it will automatically unsubscribe from it. And the first really, really cool thing that you will realize after the demo, I don't use the word subscribe or unsubscribe a single time. And in the end, we will have a fully reactive application. This is, I guess, a very big benefit, because subscription handling, or to be more specific, the memory leaks that result from it, are painful and very hard to find, and you have no chance to run in it by using it. And now I have this state, and I can say I initialize my state with my initial state, and therefore I can use the method set. So I can imperatively set the initial component state. And this was already a small hint. I use this imperative set method to also fix our input binding. So for sure, you can use write your decorators that turns it into a stream, but maybe you have to do some logic or other stuff. So it's a very good way to hook into declarative, imperative functions, uncomposable functions. And how can I use it? I can say I use set state, but instead of inserting the initial state, I can insert an object which has its key, refresh value, and the value refresh value. Here I just use the shortcut, and this is the moment where I add, or I set the refresh interval to a specific number after this line here is valid. This is called a partial update. So if you are used to write reducers in NGRX, you always have to retrieve the full state and return the full state. What I do here is I run partial updates, and you just apply the slice that you want to change, and the rest is done under the hood. This saves a bunch of lines of code, and you can also have a clear mind on managing only one slice at a time and not a full set of actions and everything. This is one way to connect uncomposable methods to the component state, and the second way where I do my subscription handling here and manage the store list. I can also show how to connect this to the state. So I basically copy out those two lines and I delete the rest. and I go here, I could do this in engine init, but as we are fully reactive, we don't care about life cycles anymore. This is the next benefit. If you code fully reactive, you mostly don't need any life cycle hook. So what I want to do is I want to connect this stream here, and let me quickly explain this. This is from my list service, which could be the global state management in any library, ngxs, ngrx, whatever. And you get a list of items, and then I map it, and I turn the server object into a client object here. I just plug out only the ID and the name. The rest is data that I don't need to display or process. And this is done in this line. So this is an observable of items. And now I can use the connect method. And the connect method helps me to connect an observable to my state without using subscribe. What I can do is I can put in here an observable of partial t, an observable that returns some partial of my t, as this would be an example of a partial of my state. Or if I'm lazy, I can also name, and here, of course, I have auto-completion and everything is fully typed. I can say under this key here in my state, connect me this observable, my refresh list. And if I do this, sorry, this is the list. And now they're typing. Now you see TypeScript is working. I cannot apply the wrong value. And now I basically say, whenever this observable emits a value, I update the list state. And whenever the list state changes, I update my template because there is an async type or an NGR, a let type or another reactive thing. And these are two ways how you can connect different things. I also could connect changes from my template. I have an expansion panel here that is changing its state whenever I click it. And I can, in the same way as I do this here, can say, okay, I want to connect this observable here, and this observable is returning me a partial, and this partial can be created here. Whoops. I receive a Boolish value, is it open or closed? And what I return is a value that says list expanded and then the B, the Boolish value, and I return this, and now I do a partial update by returning one key value pair or multiple. I could also return a set, and you could apply some refresh interval to here. As you can see, you are pretty flexible, and if you need to do really something specific with the last value of the state and the new value, then you can also pass in a callback function. You receive the old state, you receive the new value, and you compose it, and the result of this function is then connected to my key here. So you see, whatever way you want to connect any observable outside of an uncomposable method or from your state classes which provide observables directly to this state. And if we run the demo,
but Mike, how do you get the values out after you connect?
How do you get the values out? This is a good question. Let me introduce something that is called $. This is called ViewModel. ViewModel, let me write it. ViewModel. Because before I also had the concept of a ViewModel, right? And this ViewModel is already imperatively implemented in my code. I worked with object mutations before. And now I can say, okay, I want to have a reactive ViewModel. So what I do now is I can say this select, and then I can either slice out a specific state, only the list, for example, or I write nothing, then I get the full state out of it, or I can also, and now the really cool part comes, apply operator directly. So my interface is sticking fully to reactive, to the reactive API, and you can do whatever you want here. The really good stuff about the select operator and why it is a replacement for pipe. Normally you write observable.pipe, here you write this state.select, is in state management, you care about changes. So you want to only render distinct values. In state management, you care about undefined. You don't care about undefined values because state could not be set yet, right? RxJS is lazy and you don't care if the state is not present yet. You don't emit. This is also filtered out. And if you would subscribe multiple times on this observable, all the expensive processes in the middle would get shared and replayed automatically to all the other new subscribers. So it takes away the full mental model of how can I share and treat this stateful stream with other parts of my application. I only focus on the behavior and the distinct until changed, filter out undefined, share replay last. Share replay 1 is done under the hood because you would have to apply it anyway all the time when you select something that is stateful. And then you can use this observable in the template. And I scroll here and I implement ngIf. And then I do the hacky trick. My observable.async as VM for ViewModel. And then I can go down here and replace everything that was previously done with manual stuff. What is the problem? Why are you a...
I think you have that map where you just you didn't get the
you
list.
You are smart.
Oh, no, I just was observant. Okay,
so perfect. I want the full state, but you see TypeScript, this is fully working. It is typed. So here, now this is working, and now I just use my ViewModel everywhere. Right here, and right here I can get rid of the full stuff. I can delete this. I can write ViewModel here. And here, and that's it. Now I'm done. And the cool part of it is VM is now the only place where my state lives. Isn't that cool? If I look in the template, I know that everything sits on my ViewModel, and maybe I can introduce a rule. Oh, I can also get rid of this. Give me a second. This is also implemented, and this is also VM. So those things are now all reflected into one single object. You have your single source of truth in the template where your state lives. And for the old programmers under you, maybe you remember AngularJS, and there was a time when there was this ViewModel proposal thingy. This is a really good example of the same concept. So we introduced this ViewModel stuff, and we can get rid of a lot of stuff now. We can get rid of this one, and we could also get rid of this one. And instead of using an event emitter for the output, I can also just say this dot select. And in this case, I'm only interested in changes from the list expanded state. Bam, this is my output binding. A one-liner, no event emitter emits something, no callbacks, just right there what you want to have as output, and then you're done. And the rest of the code is deleted.
Quick question on that there on line 118. So by using the select method there, is that only going to fire whenever list expanded changes?
Yes, because we have the select operator.
ViewModel changes.
Yes, that's true. You are right, because the select is taking away the mental model that I treat a stateful stream. You know already that, because you asked me this question, if I treat a stream as this is my state, I don't want to have all emissions. I just want to receive state changes. And I could always use the pipe, but then I have to write it on my own, and select is basically taking away the mental model of this. I have a stateful stream.
All right, so you don't have to worry about the distinct until change.
Exactly.
That's awesome.
You can also dig deeply into an object by providing more key value pairs here, if you want, if you have a fully nested state. And you also know that you can have any operator here. So I'm pretty sure you can solve your problem by just using rxjs and no special API that is, again, a different API to work with something reactive. Now, I really try to stick with rxjs interfaces for the full library set. Isn't that cool? So let me stop the sharing quickly that I can see your pictures and your faces. So normally we write a decorator to get imperative stuff like the setter method in the input binding. Normally we have to subscribe to something and unsubscribe from something. I could get rid of all of this. There is one single piece missing where I could use the word subscribe. Can you guess where I could use the word subscribe, which is not related to state management? It's tricky. It's something that is not related to state management.
At the component level?
At the component level, yeah.
With the async pipe?
Okay. You could use the you could use the async pipe to do the trick. What I'm speaking of is background processes or side effects that are not related to my state. For example, every 10 seconds, I fire an HTTP request and refresh the list. This is a background process that the firing and the triggering of the HTTP is not stateful, but maybe the later on state change will then drop in. So how can I maintain this tick that fires an HTTP request? This is maybe my last quick code example that I show you before we can go to the performance stuff. So if you look here, you have subscription handling and all the other stuff. And if I jump into my solution,
Mike, you're not sharing your screen anymore.
Why not?
You turned off your screen share so you could see our faces.
That's true. So let me jump in, show the last line of code whenever I have to.
Hey, while you're doing that, Tobias wants to know where he can find your code, Mike. Do you have this on a public repo somewhere that they can see it?
Yeah, it's called RX Angular. It's a repository, and I tweet about it.
Okay, and Hans said you could do all of this with pure RxJS, so they can do all of this functionality without the library that you wrote, but you're just saving them some work. Is that right?
Well, yes. What I saved them is the subscription handling in stateful streams, in unstateful streams. I take away the mental model of distinct until change, share replay one, and filter out undefined with the select operator. You can still, as you can see, write reactive code. What I do here is I merge a button click and an interval that is ticking every 10 seconds that is triggering automatically with a tap operator with a side effect, the refresh list method. And this is also managed here. So you really write normal RxJS, you just don't do the clutter. Look at this class here. That's it. If you remember the initial stuff, when I undo all my changes, it is like at least 70 lines of code more with the same result. So if you scroll here, you have the subscription handling, the subscribe, the unsubscribe, the on init. If we go back, there is not a single lifecycle hook left here. So no lifecycles, no subscription handling, no mental model of state management. Just like having the interface and know what keys you want to maintain. List expanded, list, whatever.
So that's what this hold method is to handle these side effects?
The hold method is subscribing to an observable, and this observable is performing a side effect that you can see here. And if you want to write really nice and separated code, you can also cut out the side effect. Now you have only the tick. This is now a trigger, and we can take the trigger and fire this method here. And then you see trigger is here, side effect is here. There is no state change related, but we still need to do subscription handling. And you can do this with the hold method.
Okay, so the hold method is, I can give an observable. When I call the hold method on it, it'll handle the subscription to it.
Yes.
It'll fire it up, start it up. It'll also handle cleaning up the subscription for me.
Exactly.
And then with, like you said, that second argument, I can say, hey, when data comes through the subscription, when a value comes through the subscription, I could take action on it. I could do some other stuff.
And you use it whenever you don't want to maintain state. If this would return stateful stuff, then you take the observable and connect it to your state slice. But if it is not related to state management, you want to just hold it, the subscription.
And then does there support, like, how would it, if there was an error in that subscription, right? Would I be able to write code here to do something on that error?
For sure, you can write normal rxjs. So you go here and you say, oh, you can move it in here. To be more specific, let me close this line here. So this is my stuff. Let's say there could be an error. You could catch it, whatever you want. It is really plain rxjs what you write. There is no, I don't provide a new way, a new API. I just take away the clutter that is needed to do state management. But how you manage your state is up to you. And this is the really cool thing. I don't force you to use a paradigm. If you are happy to go with the commander pattern, go for it. You will end up with way less code than implementing the subscription stuff on your own. If you go for this CQRS pattern-like stuff that is implemented in NGRX store, you can go with that approach, implement that pattern. I will not interfere with your decision on architecture or whatever. And in the end, what we do is we anyway end up with one-liners. I barely have situations where I'm not able to do whatever I want with a single line of code with this setup here.
Very cool. Very cool.
There is only a couple of minutes left.
I have a quick question before you do. At the onset, you mentioned two different libraries. You mentioned at Rx Angular /state and /template.
Yes.
You're doing a lot of talking about the state. Do you have anything to show about the Rx Angular /template?
Exactly. This is what I want to show now because I really
am out of your way. You go right ahead.
Perfect. Sorry. So what I wrote is what I also, so the same thing here, two things, the push pipe and the let directive I implemented in the NGRX repository already, and I created a separate, way more performant implementation of the same two pipe and directive that I created for NGRX, also for this library. And this is the really cool thing. And I found a design document. This is basically my pick of this call. This is the design document of Miško that is talking about Angular's change detection mental model in Ivy, which is just a design document and will end up somewhere in the future in Angular. And guess what? I have the code running here in this very example. And now I want to quickly introduce you to problems and to some ways of rendering, and then we hopefully quickly can talk about what the performance optimization is. So when you render Angular, and now I will rush a little bit more than before, it is basically done top down, right? The application ref calls tick, and then you walk down the tree, and then you render the full application. And if you use change detection on push on a specific component, you can only re-render it when there is a change. So this is already a small performance improvement. If you use it everywhere, you still have the problem that people forget to put it there, and then you end up with this over-rendering. And if you believe you are smart and you put a linting rule to put this over everywhere, you still have Zone.js, and Zone.js will mess up your performance. So these are valid things to improve it a little bit, but not enough if you ask me. So I implemented the pipe, which is similar to the async pipe, but you can configure it with three different methods, with three different rendering strategies. The global strategy, which is nearly exactly the same thing that the async pipe is doing, but with the big difference that this will also work zoneless. Then you have the local strategy. This is kind of what would happen when you call change detection reference detect changes, but my stuff is way more performance. And then you have detach, and detach is a very special render method that detaches your component from the view. Whenever you receive a new value, it attaches the DOM again, renders the state, and detaches it again. If you think about it, if the component's template is detached from the component tree of Angular, not even Zone can interfere and re-render unnecessarily. And this is implemented in the push pipe, where you can use it like this with the column, or in my rxlet directive, which I have here. And you can use those render
Mike, you're not sharing your screen again.
No.
I'm sorry.
Why can't you interrupt me?
I did.
So I share my screen again. I have no time left. Everyone is smiling, you know why? Because I am stupid now. Okay, look.
I just assumed you knew. I thought you were just trying to get through it.
Good that we are in AngularAir, where everything is allowed. Okay. I created a push pipe and a let directive that where am I? You confused me completely and I confused you. Blah, blah, blah. We go here. This is how you can use it. A pipe and a directive, and you can configure it with a strategy, with those 3 strategies that I talked about. The global strategy is going bottom up, top down, as Angular async would do it, but it still over renders. The local strategy is only rendering the very component and nothing else. And then there is the detached strategy where I will also get rid of Zone.js and only render every change when it is needed by reattaching and detaching the components template for every change. And
that sounds scary.
Yes, but it works. The only problem is you can really only use it if you mark the full path of the component tree with this decorator. This is the current state. We still work on making it easier, but you will use it anyway in those edge cases where you need really the last bit of performance. The local strategy itself is bringing incredible performance. It will bring you, let me quickly jump here, instead of 12 renderings in an example that I run here, I normally Angular runs 12 re-renderings, then I implemented the principle of coalescing, and I coalesced multiple synchronous emissions into one. And in this example, I end up with 4. And then I scoped all those coalescing of the push pipe, the let directive, the component class together in one scope, and then I end up in one single rendering where Angular nowadays would do 12. And this is the real big performance improvement of this template rendering. And I have to rush. So I demonstrate multiple subscriptions to observables in the template and also static rendering, then multiple synchronous emissions of one observable and multiple synchronous calls of declarative non-reactive render calls. And render, you can imagine as calling detect change just with a wrapper. And Angular does it 12 times in this example, and I do it 1 time. The first thing that I implemented is coalescing. So if you have a synchronous task, synchronous code, this is in the first block. Then you can have a micro task, which is a promise. This happens in this I block here. Or you could have a set timeout, which is a macro task, and this is this block here. And what my operator is doing, it buffers all the values that happen synchronously in the same browser tick, and they will replay only one value whenever this synchronous code is done after the synchronous code. And this helped me to get down to having 1 emission in the component class and 1 emission in the template in this very, very limited example. And then I introduced another concept, scoped coalescing. I know it is very, very technical, and I missed to start directly with this and only explain the technical part slowly, but time is running. So we have 2 different scopes, the scope of the component class and the scope of the template. And then for every single directive you use, you also have those scopes. And then you have, again, unperformant renderings. So what I did is I said, I find something that I can share between all of them. And this is some internal part of the change detector ref that is called the context. And the context is, if you look deeper, directly related to the L view of Ivy. And this is the same instance across here and here. And with this trick, I was able to go down to a single rendering for no matter what you will do. And this is what I'm really excited about. The local strategy the way to start using it in a template with the async pipe or the let's directive, and going down to this one piece here. And in the future, I will work on a full set of reactive tools. I will ship the rxif, the rxswitch, the rx4, and you can basically throw an observable in the template. Whatever you would need as functionality, it is there. I end the screen sharing. I go back and I give the word to you, and I'm sorry that I talked all the time and I rushed and we had no time and I didn't share my screen and it was funny and raw and chaos.
That was awesome. That was awesome.
Oh,
So-
it was. I only wish we had another hour so we could go through some code. I freaking loved
the
it.
cool part is the rendering stuff, which is really deeply technical, and I could explain a lot about it, but I started with the wrong topic.
Yeah, we'll have to
Make
schedule
another one next year or in a couple of months.
Yeah.
follow-up episode for sure.
Yeah. I have a question then. So with that, with modules, and you were providing your own module for this to provide essentially like parallel implementations of those directives, is it possible that if you were to become feature parity with common module, that we could configure this at the root level of an application to provide your module instead of common module, and
You
use the same
are
name?
brilliant. You are fucking brilliant. Seriously.
Oh, you might.
Brilliant.
I'm muted, but you're not muted. Did you hear what you just said, Mike?
We have to go 5 minutes. I just need a bit more info on this, and I guess I cannot sleep tonight because I'm so excited.
The only issue that I see with that is that you are changing the signature of the async pipe.
No, I just don't ship the async pipe. I call it push pipe. No, you are true. I have to really mirror anything. No, I don't change the signature. I just add another parameter.
That's true.
It will work. Non-breaking change. Bam. Very cool. Yeah, you can use it as a replacement.
I'm so excited.
All right.
Very cool.
I think we have to wrap, you guys. Don't
Don't
forget.
boss us, Bunny.
Yeah, why did you tell us we have to wrap? Oh, we have to wrap.
There's a reason they call me NG Mom, you guys.
We're gonna schedule another episode for sure. But let's get to some
I will
picks.
be everywhere.
Have any picks, and then we'll wrap it up. So, panelists, anybody have any picks?
Right after this, you guys stay tuned on the YouTube channel because we have Jeremy Elborn talk about Angular CDK and material. It's going to be very cool. That's
Awesome.
my pick.
Mike, Alyssa, any picks right now, or?
No,
Mike
I'm
has
good
one?
right now.
My pick is the design document that is implemented in my code. It is in your channel. You can blah. There is another link that I will read later on. Thanks, Mike. Hi, Mike.
Hi, Mike.
Hi,
I
Mike.
should have yeah, my bad. That works. Thank you, Mike.
More fun with other mics around, like Mike Ryan and Mike Harding said.
Oh yeah, no, that would make a lot more sense. You're like
Oh,
a bunch of one of those like birds that are like mine, but you're all like Mike.
Mike.
I have a mic, though. Alex Eagle put out a blog post about the future of Bazel and Angular. I put the link in our chat here that we can share out as well.
Nice.
But it talks about the future of Angular and Bazel and that relationship there.
Nice.
Michael, I wanted to know, is there like a blog post or just the repos? Like if people really want to dive into these two.
This is a good thing. So the state management part was a research that I did in 2019. At the end of 2019, I presented it. It was, you just search for reactive component state, tackling reactive component state. Then I did another talk on only the component state. And now I slowly switched to the template stuff. So the next talk that I will give online is only focusing on rendering strategies and these really low-level optimizations in the browser. And I will do more like that you really can see how impactful this strategy is, not only in numbers and slides, but also in demos. And this is what I'm working on at the moment. And as a small teaser, I use the main thread scheduling post task API, which is a Chrome Canary, whatever experimental feature right now. in my code base, so just that I'm prepared for the future, you know.
Very cool. Very cool. All right. Well, Michael H., thanks so much for coming on. Really, really appreciate you taking your time and doing that. Thank you.
Yeah, I had a lot of fun. Thanks for your time too.
I've got
We'll do a follow-up episode to get the more content. So
yes,
we'll connect.
I've got this.
Awesome.
Bye, Mike.
Bye, Mike.
Mike.
See ya. Have a good one.
Bye.
All right, we'll see